Okay, so topic is private VLANs. Now, private VLAN is one of the way by which you can control intra VLAN communication. Now, private VLAN works on the concept of parent and child. Basically, when I'm saying that how does private VLAN works, private VLANs work on the concept of parent and child theory. Now, what do I mean by this? When I say that there is a that we are having parent, and from the parent we are the hybrid, right? We are the hybrid of our mom and dad. So similar goes with the private VLANs. Private VLANs do works on the concept of parent and child. Now, what does it mean? So that means there is going to be a VLAN on my switch which will be configured as the parent VLAN, or you can say the primary VLAN. And for this VLAN, let's suppose you have configured VLAN 100 as the parent VLAN or the primary VLAN on the switch. So this VLAN 100 will have its own you can say own VLANs. So let's suppose VLAN 2 and VLAN 3. So I can say VLAN 2 and VLAN 3 are nothing. These are just the children's, or you can say the subordinates of the this primary VLAN. And fine. So let's discuss about how you can use the private VLANs in the real-time environment. Basically, I would like to give you a design perspective that usually the network engineers do have this have misconception, or you can say the confusion, that what's the difference between a VLAN and a private VLAN. They do work exactly similar. Yes, that's fine. But you need to understand that how you can implement the private VLAN in your network or in your organization. Somewhere with the design perspective, you will get an idea that how the private VLAN actually works. Okay, so let's suppose that let's suppose that there is an ISP. Fine. That ISP named as Vodafone. Now, let's suppose that's a city. Okay, let's name it New Delhi. Now, within New Delhi, okay, now this ISP Vodafone is having their network all over the India. Fine. This ISP is having the network all over the India. Now, within India, there is a city called New Delhi. So obviously, within New Delhi, the ISP, the Vodafone, will be having its own network. But let's suppose within New Delhi, there is a small locality or an area. Let's name it as Sector 21. Right? So within this Sector 21, let's suppose that there is an local ISP vendor. So basically, this local ISP vendor is providing the internet connectivity to the different users within this location. Now, what happens? Now, how does let's name this local ISP vendor as Nextra. Fine. So basically, how this local ISP vendor gets the internet connectivity. So what they do exactly, they take the internet connection, or you can say they take the lease line from the vendors like Vodafone. Fine. And this Nextra local vendor will purchase a lease line, or you can say the point-to-point connectivity or the STM links with the ISP. Fine. Now this local vendor now will distribute the internet connection to the users. Fine. This is how the things work. Now, considering the same design, let's suppose that this is the customer edge router of the local vendor, which is Nextra. Fine. And it has taken the internet connection with the Vodafone. So that's a local vendor, local ISP. That's the major ISP, you can say. Now, within this sector 21, there are different homes. Let's name, there is a guy living over here, Jack, Ryan, and Leo. Now, let's suppose all these users would like to have the internet access at their home. So basically, it's easy for them to approach the local ISP, the local vendor, than the Vodafone. So what they did, they purchase the internet connection from the local ISP. Fine. Now what does this local ISP is going to do? It will install a switch. Fine. The NATing will be configured here on its customer edge router. This local ISP has gotten public IP. Fine. And it will provide the internet connectivity to all the three users within the same locality. Fine. Just try to now try to understand. Basically, when you are saying that these users are in the same locality, when these users are going to get the internet connections, or you can say when these users are going to get the IP address, basically they are not getting the public IP address, but instead they are getting the private IP address. So basically you can say these users are the LAN of this local ISP. Fine. And they have installed their router over here. And with this router, this user is able to access the internet. The traffic will move to the switch. This switch will forward the traffic to the core router, and core router will forward the traffic to the ISP. This is how the things work. I'm just giving you a perspective, the design, how these local vendors or local ISPs are using their internet or providing the internet connections to the different users. Fine. Now
Wait,
think from the
hello.
Yes.
Prashant.
Yes, Tarun.
Sorry, as this is some out of the scope question, but as this is a security class, so I always have the curiosity to understand this concept. Let's suppose the person Jack is bad guy, okay, and he do some hacking or what you call that IP snooping or spoofing vagara and all that
Okay.
stuff.
Yes.
Okay. So he do that, and he do deep web, dark web, and all those stuff. So how would we identify? But he's not getting the public IP. He's in private ISP, and the private ISP give him the address. How would they identify him? I mean, I hope you understand.
See, when
If
you are taking
police capture local ISP, right? Or police capture him, Jack. How would they identify him, Jack?
So when it see what happens when a packet is, let's suppose that from the perspective, hold on, let me just resume the recording. So now try to understand the queries from this owner of this local vendor. Okay, he is providing the internet connections to the different user in the same locality. Right now I told you that all these users, Jack, Ryan, Leo, basically they are in the LAN network of the local ISP. So that means they are provided with the private IP addresses. You can say they will be in the same network. Let's suppose this user has got the IP 192.168.1.1. It is getting 1.2 and this user is having the IP address 1.3. Now try to understand. From the owner's perspective, he will certainly have few queries. The first question is, or the first query can be, I do not want users to use my resource to communicate with each other. Basically, this owner does not want these users should use the resources of the owner. Now, what does it mean? See, just try to understand. Let's suppose the Jack, Ryan, and the Leo, they are best friends. They would like to play some LAN games. Fine. For example, Counter-Strike. So what do you need to do for the LAN gaming? They just need to have the reachability over the LAN network, and all the traffic that will be exchanged between these three users, the traffic will move to the switch will forward to these users, right? So basically the owner may have this concern that when these users will try to communicate with each other, they will be using the resources of the local vendor, and the local vendor basically has the purpose to provide them internet connectivity. That is it. Basically, this local vendor would like that this traffic should be forwarded to switch and should forward to the internet. That is it. The owner of the local vendor would not like the communication to be happen between these users. Fine. Second thing, there might be some security concerns. Security concern means, let's suppose if these users will be able to access each other, fine, using its resources. So this Leo might be an attacker who would like to steal some information. He would like to bring down these users out of the network. He might do some unethical things with these users. So basically, keeping all these things in the mind, owner decided that he would like to configure such a solution on the switch so that these users should not be able to communicate with each other. Fine. And simultaneously, they should be able to reach to the internet. Fine. Let me give you another perspective. Considering the same design, customer edge router, that's the local ISP router. Then there is a switch, and then we have three users, Ryan, Leo, Jack. Let's suppose that two new users also being added in the network. Okay, let's name them Ria, Mia. Fine. Now, when these two users purchase the internet connection from the local ISP, they told the owner very clearly that we would like to have the communication with each other. Basically, they would like to transfer the traffic directly with each other. As simple as that. So basically now the local ISP have two things in the network. The first thing is these users should not be able to communicate with each other. The RAN should not be able to communicate with Leo, Jack, Mia, Ria. Fine. Also, the ISP has to make sure that these two users should be able to communicate with each other, and they should also be able to reach to the internet. Are you able to understand? So the owner would like to implement such a solution on the switch that he shall be able to achieve both the things. That if the owner would like to segregate the users, he shall be able to do that. And if the users are requesting the ISP to let them communicate directly with each other, this should also be possible. So keeping these things in mind, the owner come up with the solution that I will implement the private VLAN on my switch. Now, try to understand. That's my router. Again, it's connected with the ISP. There is a switch over here. Then the three users, Ryan, Jack, Leo, and the two another users, Ria and Mia. Now, what does private VLAN says? Private VLAN says that first of all, you need to configure, you need to define a primary VLAN on the switch. Fine. So let's suppose on the switch, I have defined that VLAN 100 is going to be my primary VLAN. Fine, that's the step one. Now, step two says in the private VLAN says that you need to define secondary VLAN. Fine. Now, secondary VLAN can be of two types. The first one is isolated VLAN and the second one is community VLAN. So basically, community VLAN means that the users will be able to communicate with each other. If I find an isolated VLAN means the user will be completely isolated. He shall not be able to communicate with each other. Try to find. So first step is that you need to configure a primary VLAN on the switch. Second step is to configure secondary VLAN. Now, how many secondary VLAN you need to configure? I told you that there are two types of secondary VLAN. So let's suppose that on the switch, I told that VLAN 2 is my isolated VLAN and VLAN 3 is my community VLAN. Fine. Now, since I want the users Ryan, Jack, and Leo, they should be in the same VLAN. Why they should be in the same VLAN? Because they will be having the same private network of the customer, right? The customer, the local ISP, this is the local ISP private network, right? That's the LAN network. So obviously they will be in the same network. So, so the local ISP would like to have in this have these three users in the same network, in the same VLAN, but they should not be communicating. So if I configure these two ports of the switch in VLAN 2, now VLAN 2 is isolated VLAN. That means when the two ports of the switch configured in isolated VLAN will not be able to communicate with each other. Fine. Now, also I will configure this port of the switch as in VLAN 100. So what happens? Since this is secondary VLAN will always be able to communicate with the primary VLAN. So either it is isolated VLAN or it is community VLAN, they both will be able to communicate with the VLAN 100. So that means if Ryan will try to send any traffic to the internet, the traffic will be received by the switch will forward to the router, because this secondary VLAN 2 can communicate with the primary VLAN. Fine. Similarly, when this user Jack will try to send any traffic from VLAN 2 to the internet, the traffic will move to the VLAN 100 because the secondary VLAN can communicate with the primary VLAN. Now try to understand. But when this Ryan and Jack would try to send any traffic to each other, they will not be able to, because the users in the same VLAN, which has been configured as an isolated VLAN, they never communicate with each other. Fine. Now let's talk about the community VLAN. Now I will configure these two users. Fine. I will configure these two ports in VLAN 3. So what happens? I told you that the community means the users will be able to communicate with each other. So now if Ria would like to send any traffic to Mia, they can send the traffic. Also, if Ria would like to send the traffic to the internet, the traffic will be received by the switch. Now the switch will forward the traffic to the VLAN 100. Why? Because community VLAN is also a secondary VLAN, and I told you secondary VLAN can communicate with the primary VLAN. So with this logic, with this solution, the owner of the local ISP is happy. He says, now my users are in the same VLAN. I have isolated them. Also, if I would like the users to communicate with each other, I also do have that provision. Further, the users will be able to reach to the internet. So that's what's the logic of private VLAN says. Now you can have your queries. If you would like me to repeat these things or you are not able to understand, just do let me know. Mr. Ben, are you clear with this?
Yeah, I'm back. Yeah, I'm at the workplace now, so I just have to do some few things. I'm good. I'm good with, I know private VLAN, so good.
Okay, Mr.
Thank you.
Mike.
Yeah, I'm good. I need to, leave for a moment because of work.
Okay.
I'll join.
Okay. Mr. Tarun and Amit ji.
I'm good.
Okay, fine. Yes,
Prashant,
Tarun.
one more thing. There were in the previous classes there were some we have done some port
Protected port.
protected port. Yeah, can't we use that concept in it?
Okay. Again, Tarun, the problem is the protected port feature is locally significant, right? If you
Right.
remember.
Right. So
But this
but practically, the local the protected port, what will do? It will not let communicate these three people with each other, but
Yes.
I think the two people who want to communicate, he can put.
Okay,
So
let me just distinguish it. Tarun, the problem with the protected port is, let's suppose I want these two users should not be able to communicate with each other. Fine. I will configure these two ports of the switch with the protected port feature and they will not be able to communicate. That's fine. But the problem is, if I want this particular user, fine, this user should not be able to communicate with this user on the another switch. Fine. Let's configure this port and this port as a protected port. Problem is, when these two switches will send the user data with each other, there is no tagging on the data that the traffic has been received from the protected port. Try to understand. When this switch will receive the traffic on this port, it will come to know that I have received the traffic from a protected port. And let's suppose that the user is trying to send the traffic to this user, and this port is also configured with the protected feature. The switch will come to know that I have received the traffic on the port which is configured with protected feature. The packet has to be forwarded to the port which is configured with the protected feature. The switch will block the communication. Switch will discard the packet. Fine. But when the user will send the traffic to the switch, to this switch one, it will be forwarded to whom? To switch 2. Now when switch 2 will receive the traffic, how switch 2 will come to know that this packet which I have received from switch 1 is received on the protected port? There is no as such mechanism on the Cisco switches that they will give the information to each other that these are my ports are protected ports and these are your ports which are protected port. They do not have as such mechanism.
In case of those switches, those switches are in stack, what will the concept?
See, stacking means both the switches are going to work as a single logical entity, right?
Right.
So the protected feature will work. But again, when I talk about the multiple access switches in your network, then this concept fails. The protected feature will not work there.
Okay, got it.
So we are going to conclude this practical. I'm going to have a switch. I'll take a router R1 or R2. I'll take another two routers. Basically, the R3 and R4, I'll configure them with these IP address 10.3, 10.4, and this router will be configured with the IP 10.2. Fine. So what I'm going to do, I will configure this particular port of the switch as the with the primary VLAN. Fine. And I would like these two users, user 1 and user 2. Let's suppose I would like these users should not be able to communicate with each other, but they should be able to reach the core router, which further shall forward the packet to the ISP. So basically, I would like 10.3 should be able to communicate with 10.2. 10.4 should be able to communicate with 10.2, but there should be no communication between them. So what I can do, I can create a VLAN on the switch. First of all, primary VLAN, any VLAN. Then I will create the two secondary VLANs. Let's suppose VLAN 2 and 3. And what I'm going to do, I'll configure this VLAN 2 as an isolated VLAN, VLAN 3 as my community VLAN, and I will configure these two ports into the VLAN 2. So what is going to happen? These two users will not be able to communicate with each other. As simple as that. So that's my topology. And now I'm just going to start with the configuration. Let's configure the IP addresses quickly. We are on R2, host name R2, then config, interface E0/0, no shutdown, IP address 10.0.0.2, 255.0.0.0. That's it. Move to another router, R3. Enable configuration terminal, host name R3. And then interface E0/0, no shutdown, IP address will be 10.0.0.3, 255.0.0.0. Now move to another router, R4. Enable configuration terminal, host name R4, interface E0/0, no shutdown, IP address 10.0.0.4, 255.0.0.0. Now we see by default all the routers are configured with the same network IP addresses. They are in the same LAN. Let's try to ping them. Do ping 10.0.0.3. So R2 is able to reach R3. Do ping 10.0.0.4. Fine. Right now, R2, R3, R4, they all are able to communicate with each other. Fine.
One thing.
Yes.
How come they start communicating with each other? We haven't configured switch yet.
Now, Tarun, why do we need to configure switch? By default, all the ports are in VLAN 1.
Yes.
So basically, they will be communicating with each other.
We didn't up these ports, or we did up the ports previously.
So, Tarun, whenever we connect the cable on the switch, we do not need to run this no shutdown command. By default, the port will come up on the switches.
Okay.
Fine. So now I will start configuring the switch. Enable. If I run this command show IP interface brief, then you can see the protocol, the status is up. So what happens on the switches, whenever you plug a cable on any port of the switch, by default the port will come up in the up state automatically. Okay. Now move to the global configuration mode. You can see by default all the ports of the switch are in VLAN 1. Now we would like to configure private VLAN on the switch. Now, the most important thing to configure private VLAN on the switch is that your switch should be operating in the VTP transparent mode. Okay. I hope everybody is aware of VTP protocol. There are 3 modes of VTP protocol. Step 1, configure VTP transparent mode on switch. So VTP mode transparent. Fine. Now move to step 2. In the step 2, I will create primary VLAN. So VLAN 100, and I will call it private VLAN primary. Done. Now let's talk about step 3. In step 3, we will create secondary VLANs. So VLAN 2, then private VLAN, put question mark. I told you that either you can configure a VLAN as isolated VLAN or the community VLAN. Fine. So let me configure VLAN 2 as my isolated VLAN and VLAN 3 as my community VLAN. Now, if I run this command, show history.
One more question.
Yes, Tarun.
Why we are doing in a private VLAN community? If we create a simple VLAN,
Mhm.
so will it not communicate with the isolated VLAN, or will it communicate with isolated VLAN?
Sorry, I couldn't get you, Tarun. Your question is not clear to me. Sorry.
Let's suppose I create a simple VLAN 4. Okay, I not privatize it. Okay,
Mhm.
so what would be the case in that time? They both will be able to communicate, right? If I
No,
create VLAN,
by default, two different VLANs will not be able to communicate with each other.
no.
Mhm.
We are creating VLAN. Let's suppose VLAN 3 is there. Okay,
Mhm.
for to communicate with each other, right?
Mhm.
And if I not make it private VLAN
Mhm.
community, so
Mhm.
what could be the difference between private VLAN community and the normal VLAN VLAN 3 or normal VLAN 3?
See, when you talk about the normal VLAN or the community VLAN, they are absolutely similar to each other.
If
Okay.
they are, so what is the any specific reason they are separate, or we are just showing it for
No,
the
Tarun, you need to understand this. Right now,
okay.
we are just talking about the private VLAN. Fine. So when you talk about the private VLAN, this is how they works. You need to configure an isolated VLAN and the community VLAN on the switch. Tarun,
So if
before
I
start, you see,
Hmm.
Tarun, I think you joined a little late. That's why, because when I started this topic, I told you that the network engineers usually do have this confusion about the VLANs and the private VLAN, that what's the exact difference between them. So basically, with this design perspective, I just have tried to tell you that this is how the private VLAN can be useful in your network. Now let's talk about the traditional VLAN. If you're saying that, let's suppose if I configure simply, if I configure this is, let's forget the private VLAN. Fine, Tarun. That's VLAN
No.
2.
Let's forget only community VLAN and talk about only private VLAN and normal VLAN. Can we?
No,
Uh,
Tarun. The concept of see, this is private VLAN. When you want to configure private VLAN on the switch, try to understand the whole configuration will involve a primary VLAN and secondary VLAN.
okay.
Fine. So
Okay.
I have configured VLAN 100 as my primary VLAN and VLAN 2 and VLAN 3 as my secondary VLANs. So VLAN 2 is configured as the isolated one and VLAN 3 has been configured as the community one.
Okay. So if in case I have primary and secondary, if I create a normal VLAN here, so will that mess up things, or what will happen?
See, by default, you are using the VLAN only. See what happens if I'm using the VLAN. If you are using the normal VLAN, if you are using the private VLAN, you can configure both the things simultaneously on the switch. Okay. It is not like this. If you have configured the private VLAN on a switch, then you cannot configure a traditional VLAN. Basically, we are using the concept of VLAN only. It's just we are configuring the private VLAN, fine, to just to overcome up the customer requirement, or just to give a solution.
Okay. Got it.
Tarun, you can just understand this in this manner. Let's suppose, Tarun, you are having VLAN 1. Fine. As simple as that.
Got it.
I would like you to block the communications of all these users. Fine. Also, there is another switch. I would like you to block the communication of these users. Fine. That's a very simple task. So what are the possible ways you have?
Again, private VLAN I have to implement.
You can configure protected feature, but it won't work here. If you're
Yeah,
having the multiple,
it won't. Yes, it won't work.
you can
But private.
configure the VLAN ACLs, right? You can configure the VLAN ACL also.
But again, VLAN ACL is for towards that particular switch. Every time if I involve any switch, so again I have to create a new VLAN ACL.
Again, Tarun, the point is, let's suppose if I am having thousands of users within my network, try to understand. Now, VLAN ACL means that you will have to create the ACLs. Now creating this much number of ACLs on the switch, is it really possible?
Oh yeah, it is not possible.
You can
Exactly.
configure a switch port to a particular VLAN, right?
Right.
But creating this much number of VLANs on the switch to restrict the communication or to allow the communication, is it feasible? No. So basically, we are just coming up with another solution that if you not want to configure the ACLs on the switches, fine, you can just simply go with the private VLAN.
Okay. Okay.
So now we have created the primary VLAN and the secondary VLAN on the switches. Now the step 4. In the step 4, I would like, we need to bind these primary VLAN with secondary VLAN. So basically, I have told my switch that VLAN 100 is primary, VLAN 2 is isolated one, VLAN 3 is community one. So now I would like to bind these. So what command you need to run? You can run this command private. Go to VLAN 100 in your primary VLAN. Then run this command private VLAN associations, and then you need to use this keyword add, and then here you can define which VLANs are going to be part of this VLAN 100. So do show history VLAN 100 step 4, copy this. So basically, I have told the VLAN 100 that VLAN 2 and VLAN 3 are your secondary VLAN. As simple as that. So I have bind these primary VLAN with the secondary VLANs. Fine. Now, if you will run this command, do show VLAN private VLAN. So you can see your switch is saying that there is a primary VLAN. Fine. There is an isolated VLAN. There is a community VLAN. Just wait. Let me just execute this command again. Private VLAN association at 2, 3. Do show VLAN, private VLAN. Hold on, we will come to this output in today's class itself in the after a few minutes. Just hold on. So we have configured up to step 4. Now I would like to configure the ports on the switch, that which port is going to be the part of VLAN 100, which port is going to be the part of VLAN 2 or VLAN 3. So as per our diagram, we are having R2, switch, R4, R3. So I will configure this particular port of the switch with the VLAN 100, and I will configure these 2 ports of the switch with VLAN 2. And VLAN 2 is what? VLAN 2 is our isolated VLAN, because we do not want the communication between these users. So I will put these 2 ports of the switches into the isolated VLAN. So step 5. Configure interface E0/2, interface E0/1 with secondary VLAN configuration. Now I would like to associate my ports with these secondary VLAN. Fine. So just move to the switch interface, range E0/1 to 2, and then switch port, mode private VLAN host, then switch port private VLAN, host association, and here you need to define the primary VLAN, and then you need to define your secondary VLAN. Now hold on, I'll explain the configuration. Now you can see I have configured these two ports of my switch. I have told the switch that these two ports are going to work in the private VLAN mode. Fine. Also, I have told the switch that this port is going to be the part of this VLAN 2, and this VLAN 2 shall be able to communicate with VLAN 100 only. Fine. So basically what VLAN 100 is primary, VLAN 2 is secondary. Now, and what about interface E0/0 of the switch? I will configure this port into my private VLAN. So what do you need to do? Just move back to the switch. Interface E0/0, sorry. Step 6, configure interface E0/0 with primary VLAN. So interface E0/0, switch port, mode, private VLAN, put question mark. Can you see there is something called promiscuous? So what does this promiscuous means? I just told you that if this port is in VLAN 2, this VLAN 2 port will be able to communicate with the port VLAN 100 port. If this port is VLAN 3, this VLAN 3 will be able to communicate with the port which is in VLAN 100. So basically the port which you will configure with the primary VLAN, that port is known as promiscuous port. So basically you can say that all these ports of the switches will be able to communicate with the promiscuous port. And what is promiscuous port? The port which will be configured with the primary VLAN. So basically with this configuration, I have told my switch that this port is going to be my promiscuous port. That means this port will be configured under the primary VLAN.
Mean to say no need to give the gateway.
What?
The gateway, no need to give the gateway.
No, why would I give a gateway?
So only the promiscuous is kind of work for me as a gateway. I mean, it will only communicate with them and take the routes further, right?
Right. Now next thing, switch port, private VLAN, mapping. Now I need to define my primary VLAN and then the secondary VLAN 2, 3. Done. Do show history. Now with this configuration, I have told my interface E0/0 of my switch that you are going to be part of, you will work as a promiscuous port and you are going to work in VLAN 100 and you will receive the traffic from VLAN 2 and VLAN 3, which are your secondary VLAN. Fine. And now if I execute this command, show VLAN, sorry, show VLAN private VLAN. Now you can see the output, show VLAN private VLAN. See what does your switch says. Copy this output. So that is the output that we received from the switch when I executed the command show VLAN private VLAN. Fine. That's the output of show command. Now see, what does your switch say? Switch says that there is a primary VLAN configured on me and that VLAN is VLAN 100. That's fine. There are secondary VLANs also configured on me, which are VLAN 2 and VLAN 3, out of which VLAN 2 is isolated VLAN and VLAN 3 is community VLAN. Fine. Now come to this output. Now your switch says that Ethernet 0/1 and 0/2 are working in the isolated VLAN, that is VLAN 2. That's right. I have configured these two ports of the switch in the VLAN 2 only. Just wait. But what about this interface E0/0? What about this interface E0/0? You can see. And switch says that interface E0/0 is part of both the VLANs, isolated VLAN and community VLAN. Why? Because Ethernet 0/0 has been configured as the promiscuous port, right? And I told you that with promiscuous port, whether the port is in VLAN 2 or VLAN 3, that means any port will be able to communicate with the promiscuous VLAN, right? That's why the promiscuous port is shown in both the VLANs. Tarun, is it clear to you?
Yes, very much.
Okay. Finally, we have performed all the configuration which is required for the private VLAN. Now let's see if R4 is able to ping R2. R3 should be able to ping R2, but there should not be any communication between R3 and R4. So move to R2, ping 10.0.0.3. The ping is successful. Ping 10.0.0.4. The ping is successful. But move to R3. Try to ping 10.0.0.4. You can see the ping is not successful, and that's how the private VLAN works. Now, let's suppose that if you would like, within our topology, let's suppose you can add 2 more users. Okay, and now you want these 2 users should be able to communicate with each other. So what I'm going to do, I will configure these 2 ports in VLAN 3, and the VLAN 3 is what? VLAN 3 is my community VLAN. So these 2 users will be able to communicate with each other. Also make sure that the ports, the isolated VLAN and the community VLAN, they also not communicate with each other. Fine. And that's all about private VLAN. You can check the configuration part. If you are not able to understand any command, you can just let me know. Rest, that's the whole configuration. Now we are going to talk about DHCP snooping. So basically DHCP snooping is you can say the L2 security feature on the switch. Fine. Now, before jumping onto the DHCP snooping feature on the switch, we need to understand something called DHCP spoofing and DHCP starvation attacks. So basically this DHCP snooping feature has been evolved is a solution to overcome the problem of DHCP spoofing and the DHCP starvation attack. Okay, so let us try to understand the DHCP spoofing and the DHCP starvation. Then we'll see how DHCP snooping is mitigating these 2 attacks. Okay, so That's your switch. Let's take a switch. Then user, attacker, router, and sorry. So that's your switch. These are two legitimate users within your organizations. This is also a legitimate user within your organization, but this user is an attacker. Fine. That's your default gateway. And that's your DHCP server in your network. Fine. So basically in this design, all these users, user 1, user 2 or user 3, basically all these users are going to get the IP address from the DHCP server. Let's assume the IP address of user 1 is 10.1, which has been received from the DHCP server. Okay. The user 10.2, fine. Let's put this IP address as 10.10. Let's suppose the DHCP server is having its own IP address as 10.100. Fine. Or just this user is having the IP address 10.3. Try to understand. Now let's talk about the user 1. Fine. Let's talk about the user 1. This user 1 would like to have IP address on its PC. So obviously the PC will generate DHCP request, and in the DHCP, first of all, in the PC is going to generate something called discover message, because we know DHCP works on the concept of DORA, discover offer request acknowledgement. So your PC will send a discover message. Your PC will send a discover message to the switch. That discover message is always broadcasted, right, everyone? So it will be broadcasted by switch to all the ports. Fine. Then in the offer, the server will respond with an offer that I would like to give the IP address 10.1. It will be forwarded to user 1. So user 1 will request for this IP 10.1. This request message is also broadcasted. And finally, the server will respond back with an acknowledgement. This is how this DHCP process works, right? Now, let's suppose that none of these users have received the IP address as of now. None of the users have received the IP address as of now. It is just the server which has got the IP address 10.100 configured manually by the server and the default gateway as 10.10. Fine. Now, this user 3 is an unethical user. Fine. Basically, this user 3 would like to do some malicious activity. So first of all, this user 3 has launched something called DHCP starvation attack. Now, what is DHCP starvation? What does starvation means? That just to make someone empty, right? Just to so basically this attacker will generate so many. It will generate millions of requests. Okay, or you can just assume that there is a DHCP server with having a pool of 255 IP addresses. Okay, let's suppose the subnet mask is /24 configured on the DHCP server. So how many possible IPs are there? 255, right? Now let's suppose that this attacker has generated approximately 255 DHCP requests with different MAC addresses. So let's suppose that this attacker has sent multiple requests for the IP addresses with different MAC addresses. Let's suppose with the MAC address A, B, C, D, E, F. Now, when the server will receive the DHCP request that a MAC address A would like to get the IP address, obviously the server will respond back. So this attacker will send multiple DHCP requests with fake MAC addresses. Okay, and basically the whole purpose of the attacker is to use all the IP address of the DHCP server. So basically this attacker would like to occupy all the IP address of the DHCP server, and when any legitimate user will try to send the request to the DHCP server will not respond. Why? Because the DHCP pool has already been occupied. Already the DHCP server has provided the IP addresses to the fake MAC addresses. Are you trying to understand? So basically DHCP starvation means that attacker will try to get all the IP addresses from the DHCP server. That is called DHCP starvation attack. Everybody is clear with this? Any queries, Mr. Amit, Tarun, Mr. Ben?
DHCP starving attack. When we are talking about DHCP starving attack, so that person is on this. He can do on internally if he's on the premises, right?
Right.
On the same switch.
Yes, if he is having the access to the DHCP server.
I mean, okay. But means whatever the switch is in the premises, he can connect anywhere in the switches and can attack DHCP server from, right?
See,
internally, he have to get into the company.
Tarun, just consider. Let's suppose that's you, okay, or let's suppose that's me. Fine, Tarun. I'm a legitimate user. Fine. Whenever I go to my office, I open up the system and I get the IP address from the DHCP server. Whenever I connect to the Wi-Fi, or whenever I just get the LAN connectivity, I get the IP address from the DHCP server. Fine, Tarun.
Correct.
But let's suppose that my company is not paying me salary from the last 3 months. Now I'm an attacker. I would like to bring the services down. Fine, I would like to harm this company. So let's suppose with the help of some tools, I have occupied all the IP addresses from the DHCP server. It's as simple as that.
Yeah. Okay, got it.
So basically, I would just like to give all of you a clarity that DHCP starvation attack just simply means when an attacker is trying to get all the IP addresses from the DHCP server, and basically it would like to vacant. It would like to make the DHCP server empty. It would like to make the pool completely occupied with the fake requests. Clear, Tarun?
Clear. I like to see more examples what I can do with the company. If not pay 3 months salary.
Okay. So now once the DHCP starvation attack has been launched by the attacker, now our DHCP server or the pool on the DHCP server is completely empty. Now let's suppose that this user one, okay, it tries to request the IP address from the DHCP server. Basically, that's a legitimate user. When the user one PC will generate the discover message request, discover message is always broadcasted, right? It will be sent to switch. Switch will broadcast this request to all the ports. Now, since the DHCP server has already given the IP addresses to the fake MAC address, right? Now DHCP server cannot give any IP. All the IP addresses are vacant. Now try to understand. At the same time, when the attacker received the DHCP request, fine, it generated a fake reply. The attacker generated a fake reply that I would like to give you the IP address 10.1 and the default gateway as 10.3. Try to understand this. Fine. Now, since the switch will receive the DHCP offer message, it will forward to the user. The user PC will receive the IP address 10.1 with the default gateway 10.3. Try to understand. Now, actual default gateway is what? 10.10, but the user system has got the default gateway as 10.3. Now, okay. Now, when this user at 10.1, when he will try to reach internet, the traffic will be forwarded to switch. Switch will forward to the user 3, that's the attacker, because that's the default gateway. Now, attacker is already having the internet connections. Okay. Now, attacker will try to sniff the packet. Basically, he is just trying to sniff the packet, whatever, what are the passcodes, what are the information that is being carried in the packet. Fine. Or also you can say the attacker, let's suppose that that's a bank website. Okay, that's a bank user. Fine. Now this attacker has generated a fake website. Fine. And when this user will type www.hdfc.com on its browser, basically the request will be sent to whom? To the attacker, and attacker will use its fake website which it has generated on its system, and it will almost look like the real website, but actually it's the fake website, right? When this user will try to log in, it will enter its user ID and the password, and this attacker will be able to get all the information whatever this user is actually giving to the website. Are you trying to understand? So the whole logic, what I'm trying to tell you is that an attacker or an unethical user in your organization might give the fake IP address, might work as an, you can say, rogue DHCP server. And basically, I would like to prevent all of my users not to receive IP address from a fake, from an fake, or you can say from a rogue DHCP server. And that's why, fine. Basically, when attacker has given the fake DHCP reply, this is something called DHCP spoofing. Okay. So once the attacker has generated the DHCP starvation attack, then he has done the DHCP spoofing attack, and finally, whatever traffic is being forwarded by the user, it is actually being forwarded to the attacker, and attacker is able to steal all the information. So with the DHCP snooping feature, we would like our users within our organization should always receive the DHCP message, or should always receive the IP address from the legitimate DHCP server. That's it. That's the whole agenda of the DHCP snooping. Guys, are you all clear with the problem? All of you? Mr. Amit? Mr.
Yes,
Ben?
sir.
Mike? Tarun?
I'm good.
Okay. So I believe all of you are fine with the DHCP starvation and the DHCP spoofing. Now I would like to explain you how does DHCP snooping works. Okay. With the same topology, that's my DHCP server. That's my default gateway router. The DHCP server is having the IP 10.100. The default gateway is having the IP 10.10. Fine. That's the switch. That's attacker. These are two users. Fine. So basically, what does DHCP snooping feature does? If I enable DHCP snooping on switch, fine. If I enable DHCP snooping feature on all the ports of the switch, try to understand. So by default, all ports of switch will become untrusted for DHCP offer message. What does it means? That means if I enable the DHCP snooping feature on the switch, now when this user will generate the discover message will be forwarded to switch will broadcast through all of the ports. Now try to understand, when this this attacker would like to give a fake IP, so it will send the DHCP offer message. Similarly, the DHCP server is an actual server. Let's suppose it is also giving an offer message. Now switch will drop the offer message from both the ports. The switch will drop the offer message from both the ports. Why? Because DHCP snooping feature has been enabled and all the ports of the switch has been asked not to receive DHCP offer message from any of its ports. Clear? Now, since you would like to receive the IP address from the legitimate server only, which is connected on this port, so I will go to this port and I will make this port as trusted port. So once you configure a port of a switch as an DHCP as a trusted port, that means only this port the switch will receive the offer message. Rest from all of the ports, if it is going to receive the DHCP offer message, it will be discarded, because the offer message will only be generated by the DHCP server, not the client, right? We know that the DORA, how does DORA work? Discover is sent by whom? Client. Request is sent by whom? Client. But offer and the acknowledgement is given by whom? By the server only. Is it clear to everybody about the DHCP snooping? How does it work? Tarun?
Prashant.
Yes, Amit.
Does this concept is applicable in case of relay agent as well?
Amitji, I'm really sorry. Actually, your voice is little low. Can you please be a little loud, please?
Am I audible now? Am I audible
yes,
now?
Yes, please.
Yeah. Suppose we are using the concept of relay agent and our DHCP server is located somewhere else at remote location. In that case, is this trusted port concept will work?
Yes, absolutely, it will work. You have to try to understand. Even if you are having the relay agent in your network, just wait. That's a switch. That's router, whatever it is. That's the DHCP server. Fine. Basically, Amit, if I try to make you understand, these are all my users.
Okay.
Now, if I would like, I know that whenever I'm going to receive the DHCP offer message, I will only receive the offer message only from this particular port, right, Amit?
Yes. Yes.
That is how I'm reachable to my DHCP server. Fine. So what I can do, I can just enable the DHCP snooping feature on the switches. Fine. So if the switch is going to receive the discover offer message on any of its port, by default they will be blocked. But I'll configure this port as a trusted port. That's it.
That's it. Understand. Thank you.
Okay. So how we are going to conclude this practical? So basically, I'll design a topology something like this. I'll take R1 and R2. Fine. That will be my switch. I'll take R3. So I'll consider R1 as my legitimate DHCP server. While I'll consider R2 as my rogue DHCP server. That means that's a fake server. Fine. And I'll consider this one as my legitimate user. So basically, I want to make sure that whenever my user is receiving the IP address, it should always receive the IP address from the real DHCP server only. Fine. So let me just tell you the steps how we are going to perform the practical. R1, R2, switch, R3, which is my user. Fine. Now I will configure both the router with the DHCP server configuration. Let's suppose this router is having the IP address 10.10. This is having the IP address 10.20. Fine, guys. And I will configure DHCP server on both the routers. Now, from this router R3, I will request for the DHCP IP. Now, let's suppose that if R2 has given me the request first, I will consider that that's my root server. If R1 will give me the IP address, I will consider it is my root server. Fine. So once I'll get the IP address from any of the DHCP server, I'll consider that one as the root server, while other one as the actual DHCP server. Okay. Let me just go to the practical section. We'll go step by step and you will be able to understand this. So not to worry. So let's just follow this topology only. So R2, R3, let's consider R2 and R3 as your DHCP servers, and this is going to be your legitimate user. So let me do one thing, more action, stop all nodes, more action, wipe all nodes. I would like to remove all the configurations from these appliances. More action, start all nodes. Okay, so that's our topology. Simply, I'll configure this interface with the IP address 10.10, this interface with the IP address 10.20. Fine. I'll configure the DHCP server on both the routers. DHCP server, DHCP server. And that is going to be my client. Fine. Let's do this activity quickly. So move to router R2, first of all. No. Enable configuration terminal, hostname R2 DHCP server 1. Fine. So interface is 0/0, no shutdown. IP address will be 10.0.0.10, 255.0.0.0. Done. Now move to R3. Enable configuration terminal, interface is 0/0, no shutdown. IP address will be 10.0.0.20, 255.0.0.0. Sorry, 255.0.0.0. Host name R3 DHCP server 2. Done. And finally, my client R4. On the R4, I do not need to perform anything. I will not configure the IP address. Why? Because I will take the IP address from the DHCP server. Clear? Now just wait, hold on. Enable configuration terminal, hostname R4 client. Done. Now, first of all, just configure DHCP server on both the routers. So how do you configure DHCP server? IP DHCP pool and the name of the pool, let's ABC. Then network. I would like to configure the IP address of 10.0.0.0/24. Then default router, default gateway will be 10.0.0.10. Okay. That's it. Similarly, move to router R3. I will configure this router R3 also as in DHCP server. So IP DHCP pool, let's name it DEF network 10.0.0.0/24/8. Then default gateway will be 10.0.0.20. Fine. So basically when R3 will give the IP address, the default gateway on the client will be 10.20. When R2 will give the IP address, the default gateway on the R2 on the client will be 10.10, as simple as that. Okay, here I have configured /24. Let me just change it. No network /8. Done. Fine, guys. Now we have configured the DHCP server on both the appliances on R2 and R3. Done. Now move to router R4, which is going to work as a client. Okay. Fine. So let me just check my switch. Right now, my switch show VLAN brief. All the port are in same VLAN, so they will be communicating with each other. Fine. Now move to R4. Let me run a command. Do debug DHCP detail. So on R4, I have enabled the debugging message. I would like to see whatever DHCP message R4 is going to receive and forward. Fine. So now move to the interface. Interface is 0/0 on R4 and IP address. And instead of giving the IP address manually, I will request from the DHCP server, DHCP. Now you will see couple of log messages. Just wait. Okay, why we are not able to send any DHCP message? Because no shutdown command needs to run. Okay, now wait. Now the interface is up on R4. It is sending the request. And guys, you can see, now you can see the R4 says that it has received the IP address 10.1. But what default gateway it has received? It has received the default gateway 10.20. That means R4 has received the IP address from DHCP server R3. And I told you the client from where it is going to receive the IP address first, I will consider this one as the rogue server. Fine. And this R2 is my legitimate server. Fine. Now try to understand. What I'm going to do now, I will move to router R4. I will run no IP address. I would like to remove the IP address from router R4. Fine. Just wait. Now if I execute this command, do show IP interface brief, you can see the R4 has not been configured with the IP address because we have removed this. In fact, the log message says clearing default gateway, releasing the IP address. That means this interface E0/0 has removed the IP address 10.1, which was allocated to it. It has also removed the default gateway. Is it clear to everybody? Now I will move to switch. Now I will move to switch and I will configure DHCP snooping feature on this switch. So what happens? Once you will enable the DHCP snooping feature on the switch, the client will not be able to receive the IP address from both the DHCP server. Why? Because when you configure DHCP snooping feature on the switch, all the ports become untrusted port for the DHCP offer message, right? When client will send the discover message, it will be sent to both the server. When both the server will send the offer message, it will be discarded by the switch. Why? Because the ports are untrusted. You can see this. So move to switch and how to configure DHCP snooping feature. So the configuration part is quite simple. Move to the global configuration mode, run this command IP DHCP snooping. First of all, with this command, you have enabled the DHCP snooping feature on the switch. Since this DHCP snooping feature is implemented on the ports of the switch, so I will run this command IP DHCP snooping execute, and you can say, and you can see it says define the VLAN. So if I execute this command VLAN 1, so that means all the ports of the switch which are part of VLAN 1 will now become as an untrusted port for the DHCP offer message. Is it clear to everybody? Now all the ports of this switch which are part of VLAN 1 has become untrusted. That means if a port of the switch is in VLAN 1, it is not going to receive the DHCP offer message. As simple as that. Right now all the ports of the switch are in VLAN 1. Now move to router R4, and let us just try to send the get the IP address again. IP address DHCP. Let's see if he is able to, if the client will able to get the IP address. You can see the client is not able to get the IP address. See, it says this attempt second time, attempting third time. You can see. So that means this user is not able to get the IP address. If I run this command, do show IP interface brief, you can see the IP address is still unassigned, but you can see the method is DHCP. Why? Because both the servers are sending the offer message, and since DHCP snooping feature has been enabled, so the offer message of both the servers has been discarded. Now, my legitimate DHCP server is what? My legitimate DHCP server is connected at Ethernet 0/0 of the switch. So I will configure this particular port of the switch as a trusted port. I will tell the switch that whenever you are going to receive the DHCP offer message on this port, please accept. So move to R4. Move to switch, because we have enabled the DHCP snooping feature. How you can verify? You can run this command show IP DHCP snooping, and you can see the switch says the DHCP snooping feature is enabled, and right now DHCP snooping feature is enabled for VLAN 1. Is it clear? Now I would like to configure interface E0/0 of the switch with the trusted feature, right? I would like this switch port to become the trusted port. So what sort of command is needed? Just move to the interface, run this command IP DHCP snooping, and you can see there is option called trust. So trust. And now if I move to the client will receive the IP address quickly. Interface E0/0 of the router shut down. Let me just shut down it once. No shutdown, IP address DHCP. Fine. Just hold on. Okay, so the second attempt is there. You can see second attempt has been there, third attempt is there. That means your client is still not able to get the IP address, right? Even though I have configured this particular port of the switch as my trusted port, still we are not getting the IP address. Why? Let me tell you why you are not getting the IP address. For that, I would like to take you to the DHCP server, which is your legitimate server. Let me run this command, debug IP DHCP, IP DHCP server, and then packet. I would like to show you something. Let's see if this server is getting the discover message from the client or not. So move to the now that's R2. You can see R2 is receiving the DHCP messages, but there is something called it is saying there is an error. The error is DHCP relay information option exists, but GI address is 0. Now what is it? Okay, let's discuss this. What happens, guys, whenever this is your switch, that's your DHCP server. Okay, that's your user. Now what happens the moment you enable DHCP snooping feature on the switch? Fine, the switch is receiving the discover message from the user. It will send the discover message as it is to the DHCP server. Fine, but when the DHCP snooping feature is enabled on the switch, in the discover message it has received from the switch, in the discover message there is something called option 82. There is something called option 82, and this switch is sending the option 82 field in the discover message, but the information inside the option 82 field is vacant. There is no as such information. Wait, I would like to show you on the Varsha capture. Let me just take the Varsha capture of R2 interface E0/0. Just hold on. Remind me later. Move to R4. Send the DHCP request from the client. You can see the router R2 is receiving the discover message. You can see, guys, R2 is receiving the discover message. That's a Varsha capture of the router R2. But it is not giving any DHCP offer. Why it is not sending DHCP offer? Because if I open the discover message, you can see there is DHCP packet is there. In the DHCP packet, just scroll it down. You can see there is option 82. And if I just open the option 82, if I just keep on opening the option 82 field, according to the router, according to the DHCP server, this option 82 is not carrying the enough information. It is not carrying the sufficient information. Now, what does it mean? Now you can see option 82 means agent information. Now, what does this option 82 means? Paint. That's the user. That's switch. That's PC. That's server. Fine. So when the switch, when the user has sent the discover message, in the discover message, fine, there is no option 82. Fine. When this switch is forwarding the discover message to the server, in the discover message, it is adding a field called option 82. Now, what does option 82 means? Option 82 is actually added by the switch to tell the server that I am not the client. I am not the actual client who is requesting for the IP address. I am just acting as a relay agent. That means the switch is giving the information to the server that I am not the actual client who is requesting for the IP address. I am just the relay agent. I'm just forwarding you the discover message, as simple as that. The client is someone else. So basically, your router who is working as a DHCP server now, the router says, I am receiving the option 82, but the information in the option 82 field is not sufficient. Why? Because we have not configured any IP address on the switch. Let's suppose if I have configured any IP address on the switch, let's suppose that 10.0.0.100. So basically this switch will say, send this IP address inside the option 82 field, and the switch will say, I am the relay agent and my IP is this. I'm not requesting for the IP address. I'm just working as a relay agent. Is it clear to everybody? So there are two options to overcome this problem. Either you can just tell the switch not to include option 82 field. Either you can tell the switch not to include option 82 field, just forward the discover message as it is. Or you can configure the IP address on the switch, and then this problem will be overcome. Clear? Just come over here at R2. You can see R2 is saying the relay information option exists, but it is the GI address is 0. That means it is saying I am getting the incomplete information. The IP address is missing in the option 82 field. Fine. So move to switch. Now on the switch, since I have configured this port as a trusted port, now I will tell the switch that please do not add option 82 field. So what you can do, you can run this command, no IP DHCP snooping information option as, sorry, no IP DHCP information option. It is not able to execute this command. Why? Just wait. Incomplete command. And hold on. No IP DHCP snooping information option. That's it. So I have executed this command that I have told my switch not to send option 82 field. So now if we will request again, move to router R4, which is a client, IP address DHCP, you can see the IP address have been allocated. And what is the default gateway? 10.10. That means you have received the IP address from the legitimate server only. So the command for the this DHCP snooping is quite simple. Do show history. You can see, first of all, with this command, you will enable the DHCP snooping feature. With this command, you will enable the DHCP snooping feature on all the ports which belong to VLAN 1. And finally, you have made this port as a trusted port, because from this port, your legitimate server is connected and you would like to receive the offer message from this port only. And why this command has been executed? So that the switch, my relay agent switch, it should not send option 82 field. And just move to the Warshak capture. If I show you the last couple of the offer message or discover message in this offer discover message, did you see any option 82 field here? No, because we have told the switch not to add option 82. Everybody is clear with the practical about the DHCP snooping.